I'm Daniel Roth. I'm a product manager on the ASP.NET Core team at Microsoft. And in this session, we're going to look at what's next for ASP.NET Core and Blazor, particularly looking at what's coming in .NET 9. Excited to get to show you all the cool new features and the hard work that the team has done for this upcoming and new release. Let's go ahead and get right into it. All right, so here is a sort of a summary, a high-level view of the areas of investment that we've made in ASP.NET Core for .NET 9. Now, first and foremost, the thing I want to call out is that we've really focused in this release on quality and fundamentals. This has been a top priority for us actually in .NET 9 to the point that we've actually often prioritized this work over doing new feature work. This includes work on performance, more throughput, less memory usage, faster app load times, work on accessibility to make sure that all the UI assets that we ship can be used by as many people as possible. Lots of work on security and lots of work on tightening up and improving our engineering infrastructure. Now, I know this type of work doesn't typically get the big headlines that new feature work does, but it's critical for the long-term health of a project and also for maintaining that trust and confidence that users have in a framework like ASP.NET Core. That all said, we did also manage to do a bunch of features in .NET 9 as well. We have lots of new improvements in Blazor, our full-stack web UI framework for .NET. We now have built-in support for OpenAPI document generation in ASP.NET Core. We'll take a look at that. We've optimized how we handle static web assets in ASP.NET Core now. So all those static files can be managed and provided in a more optimal way. Some SignalR improvements for you folks doing real-time development with SignalR. We have a new multi-tiered hybrid cache API for doing distributed caching in ASP.NET Core apps. And then also various dev experience and improvements that we'll take a look at. Now we have we publish a roadmap for all of our ASP.NET Core releases on GitHub that you can find at aka.ms/ASP.NET/roadmap. Of course, as the releases progress, things do change, and they can and do change, and they have, and so we do our best to try and keep that roadmap up to date. So some things may still, I guess, adjust a little bit for .NET 9, but we're getting pretty far along, so things are pretty well baked at this point. So we're going to go through each of these areas and take a look at all the new stuff that's available to us now in .NET 9. I also want to give a call out that the ASP.NET Core team has been heavily involved with the new .NET Aspire effort. There's been several .NET Aspire talks, I know, here at Visual Studio Live, as well as some workshops. So hopefully you've had a chance to try out .NET Aspire and kick the tires a little bit, check it out. But if not, it's not too late. .NET Aspire is our cloud-ready stack for building observable, production-ready distributed applications. And it comes with a whole bunch of features for building cloud-native applications. It has a bunch of smart defaults that are ready for the cloud. This includes setting up telemetry, health checks, and resilient retry logic, so you're ready for those cloud-based environments. It has a really handy developer dashboard for inspecting and monitoring your distributed app. It handles orchestration of the various resources and dependencies that make up your distributed application. It provides a set of components, component packages to facilitate integrating with popular systems and services like Redis or PostgreSQL or various Azure services and so on. It handles service discovery so that the different parts of your app can easily communicate with each other. And it provides a comprehensive and flexible deployment model. So it's really easy to take that whole conglomerate of services and processes and get them running in the cloud. If you haven't had a chance to give .NET Aspire a spin yet, you can get started by going to .net/Aspire and build your first .NET Aspire app today. Now, one of the things I love probably most about .NET Aspire, and I know has been really popular, is the really cool .NET Aspire dashboard. It's just a really great way to quickly inspect and monitor your distributed application. Have all the traces, the logs, the various processes that make up your app right there at your fingertips. But perhaps what I love about it most is that it's built with Blazor. It's a Blazor application. The .NET Aspire team used the Microsoft Fluent UI Blazor components in order to build the dashboard, and it really enabled them to build quickly, to use their .NET know-how in order to build this great user experience. So pretty cool. Production Blazor app is now a reusable dashboard that's being deployed into Azure services as well. So pretty happy about that. So speaking of Blazor, what's new in Blazor for .NET 9? Well, these are the sort of the high-level areas of improvements for Blazor in this release. So of course, quality and fundamentals, we talked about that. Performance, security, accessibility. We're also filling various sort of, user experience gaps with the new Blazor web app model that we introduced in .NET 8 for doing full stack web UI development using the Blazor's component model. We want to make sure that all those new features that we introduced in .NET 8 really work seamlessly together. We're doing a bunch of improvements for Blazor server apps, or apps that use interactive server rendering. We're doing some improvements to the reconnection experience so that your end users don't have quite a jarring experience if the connection to your server gets lost, and also improving the performance of the Blazor server applications. We continue to invest in Blazor WebAssembly and improving our support for static web assets to optimize page load and startup time. We've done a lot of work with our friends on the .NET runtime team to also improve how fast the .NET WebAssembly runtime starts up. We've also invested in Blazor's component model and tooling to improve the overall Blazor development experience. So we're going to go through each of these and look at the specific features that make up each one. So Blazor web apps, let's make sure everyone's up to date on that. It's still fairly new. We just shipped .NET 8 back in November. In .NET 8, we expanded Blazor's rendering capabilities so that you can use Blazor to really build any kind of web UI that you want. Web apps these days can be rendered in a variety of different ways, and they each have their own unique advantages, strengths and weaknesses. Sometimes it's convenient to render your web app from the server, where you can use your server resources and access backend assets like your database and whatever to handle server requests and to then generate the HTML responses down to the client. Other times, it's convenient to render from the client, where you can handle user interactions directly and access client resources like local storage or the location data or whatever, and then dynamically use that information to update the UI. Now, Blazor is a full stack web UI framework now. It can handle all of these scenarios using a consistent component-based programming model. So by building a Blazor web app, you can really handle all of your web UI needs, no matter how you want to architect the rendering of your application. Now, let me show you a little bit about what I mean by all that, and then we'll also take a look at some of the tooling that we've been providing in Visual Studio to make it easier to get started and build Blazor web apps. Okay, so I'm going to pop over here to Visual Studio, and let's go ahead and build a Blazor web app. We're going to start from scratch using the new .NET 8 Blazor web app template. Okay, so you don't have to decide, am I going to do a Blazor server app or a Blazor WebAssembly app? You just build a Blazor web app and it can do it all. Okay, so we'll select that template and click next. Let's call this Blazor movie app. Okay, click next. And we're going to use .NET 9, the latest .NET 9 preview. I think I'm using preview 6 here. And we'll leave all the defaults. We're going to use interactive server rendering in this app. And we'll just do it on a per page or component basis. Like wherever we need interactive server rendering, that's where we'll use it. We'll go ahead and create this project template. Okay, there's our app. Let's go ahead and get it running so we can just see what it looks like and what it does, and talk a little bit through how each of these pages are actually being rendered, because it's using a few different techniques. There it goes. Okay, so building, and then there we are in Edge. Okay, so there's our Blazor web app. Now this home page, this home tab, This is just being statically rendered from the server. The server got a request from the browser. That request was routed then to a Blazor component, and that component was rendered to HTML right to the response stream, sent down to the browser, and that's why you see these pixels on the screen for hello world, welcome to your new app. So this is being statically rendered, static SSR, static server-side rendering. Now on the counter page, when we navigate to this page is actually interactive. I can click the counter button and the count goes up. We're handling UI events from the browser. This is an interactive server rendered page. It's using interactive server rendering where we set up a WebSocket connection between the browser and the server, and we can handle all the UI events from the browser by pumping them to the server, handling them, and then sending rendered DOM diffs back to the browser. So we've got a little island of interactivity within what is otherwise still mostly a statically rendered application. And then this weather page, this is being statically rendered from the server as well, but it's actually using streaming rendering where it's does an initial render to the response stream, but then it has some long-running task, like maybe it has to go call weather API or do something to get the weather data, and that takes a little while. And then after that's done, it wants to render some HTML update to the same response stream. And Blazor just sort of sits there receiving those chunks of additional HTML and patching them into the DOM client side for you. So most of the renderings in this case is still happening from the server, but it's being streamed down to the client with updates as needed. So you can have that initial quick page load, and then stuff fills in as it's ready to be shown. Okay, so that's our Blazor web app using some of the new .NET 8 Blazor rendering features. Now what I want to do is build some functionality into this app, and I want to do it fast. So I'm going to use some of the new scaffolders that we've introduced in Visual Studio for working with Blazor. For example, we have the new Blazor CRUD scaffolder, the create, read, update, delete scaffolder that will help me attach to some data and display that data in this web app. So let's get this kind of pinned over to the side. Let's get Visual Studio over here, and let's maybe give ourselves, that's not what I wanted. I was trying the other way, Windows. Okay, there we go. So now what I want to do is I'm going to add a data model to this application. Right click. I have an existing class that I've already coded up. We're just going to use that. So here in my documents folder, I've got this movie class. Let's take a look at that real quick to see what it is. Pretty simple. It's just got an ID, a title, release date, the genre, price. It's got some data annotations to specify the any validation that I want to do on this type. Okay, and then now in order to create some pages, I want to be able to store these movies in a database. I want to be able to create new ones and delete them and edit them. In order to do that, I'm just going to right-click on my Pages folder in the Blazor web app and say Add New Scaffolded Item. And I'm going to pick Razor Components for Blazor. Razor Components, the same thing. And I'm going to pick the Razor Components using Entity Framework CRUD scaffolder. Okay. And I'm going to then select which template do I want to use. I can pick individual pages that I want to generate, like just the create page or just the edit page. Or if I select CRUD, it will do them all. I can then select the model that I want to use for generating these pages. I'm going to use my movie type that I just added previously. I can then pick which database, DB context I'd like to use to connect to the database. I don't have one, so I'm just going to let the tool create one for me. And sure, SQL Server sounds good. We'll use that for our database provider. Okay, and then we just sit back and relax and let Visual Studio do all the hard work of writing all the code for interacting with the database using Entity Framework Core and rendering the data in a nice grid. Or throwing an error. What's is that because I'm still running? I don't know. Interesting. Cool. Did it actually do it? It looks like it still did it. So we're going to assume that actually worked. I don't know what that error was. I am using a preview version of Visual Studio here, so there may be some bugs. All right. So, but you can see over here, we have our movie pages that just got generated for us. We didn't have to write any of this code. And so if we look at the index.razor page, here we're getting our Blazor movie app context where we have all of our data. And then we're using the quick grid component, which is a built-in data grid component in .NET 8 to display all of the movies in a nice table. If we look at the create.razor page, this is again using the DB context. And here we've got the Blazor edit form component that we're using to create a form that's going to be based off of our movie data model. And then we'll do validation based off of any data annotations that it finds in that model and be a nice, strongly typed base form. Okay, now before I run this, we actually need to first set up the database, and we use Entity Framework Core migrations in order to do that. So I can use Visual Studio to help me out with that. I'm just gonna double click on this connected services node, and you can see that Visual Studio already knows that I'm using SQL Server for this database. And so I can use this tool to add a migration. This will add the, make sure the apps, yeah, okay. This will add the schema for my movies to the database, and it's gonna hopefully find my DB context for me. There it is, okay. So we just go ahead and add a migration called initial. And this is gonna look at my data model and look at the database and figure out what code needs to be run to set up the schema appropriately. All right, so now we have a migration down here in the corner for setting up the database, and we need to actually run it. So to run it, I'm gonna do update database, and this should find my DB context again, along with all of its migrations. Okay, there's found the DB context, looking for its migrations, and then we should be able to just go ahead and click finish to run those. Okay, so finish. Using the EF Core tooling to update the database with that schema. Cool, okay, so that's done. So now if we run the app again, there it is. Okay, so now we should have a page at /movies. And there it is. So we've got this little table. It's based off of our quick grid. We can add a movie to the database. I like 80s movies. It's kind of my thing. I don't know. E.T. was sometime in 1982-ish, I think. I don't know. I should actually remember it at some point. Nope, sci-fi is the genre, and the price is, we'll just make up a price. So add some random data. Now it's showing up in our grid. We can edit this data, and if I do something that like violates the data annotations, like try to save that, then I get validation errors. So validation is all working. So let's set that back. So it looks good. Okay, I'm gonna add one more movie just so we can do some other things. Let's add Ghostbusters. A great 80s movie, I don't know, sometime May 1980 something. We'll call it a comedy and give it another random price. And now we've got a couple movies in our database. Now we've got, the property column names obviously were generated based off of the property names of our type. We can fix those. So if I go back into the code for the quick grid, we can find where that release date column is being generated. And here we can just say, set the title to release date with a space in it. And we'll go ahead and hot reload that into the running application, and boop, there it shows up. Now I'd like to also add some interactivity to this page. Right now it's just being statically rendered from the server. We got the database, the data from the database, we rendered the page, and then Blazor's done with it. If I want to add some interactivity features, I need to now make this an interactive page. And I can do that using the render mode attribute. Like in this case, I'm going to make this interactive server. We'll use interactive server rendering for this page. Okay, and let's see. What do I want to do? I want to make let's make the title sortable. So make the title sortable like that. I think I have to restart in order to actually get the interactive render mode to apply. I can't quite hot reload that one, I think. So let's go ahead and wait for that to reload. And then if we refresh the page, you can see that the title is now selectable, right? And if I click it, then we can order the pages. So now we've got some interactivity going on. We're handling like client UI events in order to make this grid interactive experience. We've got filtering and all those sorts of things. Like why don't we add a paginator? We have a built-in paginator in Blazor that we can just use. Let's add this paginator component down here at the bottom. It's giving me a warning saying that the paginator expects a parameter called state. And that's what it's going to use to coordinate with the quick grid, like what pages should be visible and so forth. So we need a state variable. So I'm going to add a code block down here in the bottom. Let's add a pagination state field here. New pagination state, sure, looks good. And we'll say items per page. We're going to do something kind of ridiculous. We'll say it's just going to be one item per page. That's because I only have two movies. But I want to at least show that it's paginating, okay? So we'll set the state to our state object. And then up above for our quick grid, we'll set the paginator, pagination, I guess, to be that state object as well. Okay? And I think that ought to do it. Let's get the app running again. And good. Now we've got a little paginator control at the bottom. All right. So we've got sorting, we've got pagination, all really quick thanks to built-in components from Blazor, scaffolding in Visual Studio to help us connect our Blazor web app to some data. We can add islands of interactivity and also use static server-side rendering. So that's pretty cool. What about security? Like, can I add security now to this Blazor web app? We do provide authentication options on our templates. So like when you create a Blazor web app, you can choose, yeah, give me some authentication with that. But if you have an app like this where you didn't happen to check that option, there's actually a new Blazor identity scaffolder that you can use to add ASP.NET Core identity and authentication to your Blazor web application. Okay, so let's go back into here and try to do that. So I'm going to just right click on the project and say add new scaffolded item. Let's go right here. And I'm going to pick identity and pick the Blazor identity scaffolder. Okay, and that's going to generate for me a whole bunch of UI code for managing users, logging them in, forgot their passwords, profile management, all that stuff. Now I need to select the DB context I want. It's not showing me the one I already have. That's because it requires an identity DB context. And the DB context I have right now is just a vanilla DB context. So I'm going to go ahead and create a new DB context for identity, and then we'll kind of merge them afterwards. So I'll call this identity context. We'll add that. I'm going to use SQL Server. That's fine. And then we'll go ahead and generate a user class as well. This is so you can have data associated with your users that you store in the database. So that seems like a good idea. Okay, and then hopefully, well, good to go here. The Blazor identity scaffolder will add all the UI code that I need in order to log in some users. There it goes, generating the code, doing all the hard work for me. All right, great. So that did that. And now we have this account folder over here. Let me give myself a little bit more space so you can see that. And let's see all the pages. Yeah, so we got all these Razor components now for like registering users and password reset and all that type of stuff. That's all just generated for me. Okay, and I can customize it however I'd like. Now I do want to do one little quick thing here, which is merge my two DB contexts. I don't want to have two of them. I just want one. So I'm going to take the DB set off of the original one and move it over here to the identity one. And then I'm going to delete the original one. And then we'll rename this one to be what the other one was. And then let Visual Studio do that refactor for us, and that should hopefully make everything just fine. Rename everything, sounds great. Good. Okay, we just need to update the database with the identity schema now. We have schema for our movies, but not for our users. We need to add that too. So let's go back to connected services and add another migration. We'll call this one add identity. We'll let that find our DB context. This tool. Let's try building it first. Making sure I didn't mess something up. To build? Okay, yes, to build. So I think it's just was a little stale for some reason. Let's add a migration. Add identity. Hopefully that will now find my DB context. Retrieving available DB context names. What did I do wrong? Let's see the build errors. Build failed. I just built. Didn't just build? Let's try rebuilding. Rebuild. In order to find the DB context, this service dependencies thing is like doing its own sort of little mini build of the project, and looks like it's getting a little confused for some reason. Oh, am I running the app? Oh, I'm running the app. Okay. If you use this tool, make sure you're not running the app, because then it can't actually do the build. There it goes. Okay, so I was just running the app. That's why it was failing. The files were locked up. Okay, there we go. So now we added our migration. Great, and then we just need to run it. Let's update the database with that migration. Find the DB context. There, found it. Retrieve the migrations for that DB context, all the new identity stuff. And then we should be able to apply that to our app. Running the Identity Framework Core tool. And we're good. Okay, it's great. So now we should be able to run this. And with very little effort, considering all the functionality that I now have in this app, I now have a whole authentication system. So I can register a new user. Let's add myself. Type in a very secure password. Like that. register a user. It has an email confirmation flow. During development, you can just click the link to say, yeah, I've confirmed my email, but in production, you'd actually want to set up an email sender and all that. Okay, now we have a confirmed user, so I should be able to log in. Let's try and log in as myself. All this UI built using Blazor. There we go. Okay, so we're logged in and we have our account profile page where we can see our profile or what our email is, change our password, set up two-factor authentication, and so on. Okay, full authentication system. Now, let's go ahead and get our movie page to show up here in the nav, the left nav here. So in this nav menu, I'm going to go ahead and copy one of the existing sort of tab links that are there and add another one. We'll just call this one, this will link to the movies URL, and we'll give it a friendly name of movies. And what I want to have happen is does that show up? Yeah, okay, so now we got our movies tab. I want that tab to require authentication. Like you can't go see the movies, you can't see my movies unless you're authenticated, okay? So I'm gonna go into my movies folder, and that's what we're gonna do. I'm gonna do Control-Shift-A to add an item, yeah. So _ imports.razor. Imports.razor is like a way to import a bunch of Razor directives into all the Razor files in a certain directory. And what I want to add in here is just an attribute to say that everything in this directory should require authorization. You have to be logged in, basically, in order to browse here. Okay, so we'll add that, and that's good. And then we should be good to go. So now, if we go back to the app, okay, so I'm not currently logged in, but if I try to browse the movies, I'm going to click on the movies tab. Actually, let me go to home first. So I'm at home. I'm going to click on movies now, and I get immediately bounced over to the login page. So now if I log in, because I need to be logged in to see that tab. And if we log in, we're back to our movie. Okay, so there we did. Created a Blazor web app. We used interactive rendering, connected to some data, and also we're able to add authentication to our Blazor web app pretty quickly. You know, just a few minutes. Pretty nice. All right, let's go back here. So that's how you can build, full stack web UI apps with Blazor using the new scaffolders in Visual Studio. Now, based on some feedback that we got from .NET 8, we know that there are some areas for improvement with Blazor web apps. And so there's some things that we want to do to try and make using all the Blazor web app features a little easier to stitch them all together. One piece of feedback we got is that, we have all these render modes now, interactive server, interactive WebAssembly as well. We even have this auto render mode where it's kind of like a mix of the two, where you start them out with Blazor server, like interactive server rendering, and then you download the WebAssembly runtime in the background and then swap them over to run on the client when the runtime's already been cached. For component authors, it can be a little difficult to know, how is my component being rendered? I might want to render my component differently depending on which render mode is being used. So in .NET 9, we're adding some APIs so that you can detect what the current render mode is. We've also got some feedback that sometimes you really want most of your app, oh, excuse me, got a little croaky. You really want your whole app to be interactive. Like you set up your app to be globally interactive, like a traditional Blazor server or Blazor WebAssembly app. But then you want to just have some pages that are statically rendered. The identity pages are actually a good example of that. Those need to be statically rendered from the server because they have to do things like set cookies. And you can only do that when you're in the context of a request reply. So we needed a way to make pages be statically rendered when the app is otherwise interactive. So we added a way to do that in .NET 9 as well. The Blazor web app template also today doesn't have an option for setting up Entra-based auth, or the old name Azure AD-based authentication. We know that's a big gap. We're working with the Entra team to actually add that option, and also the Visual Studio tooling team, so that you can re-entrantly add Entra-based auth to a Blazor web app. At this point, it looks like that's actually going to probably happen a little after .NET 9 at this point. So we're working to add docs and samples to make that really easy for you to be able to configure manually. Okay, let me show you one of these features, the new API for detecting the current render mode. This will be a good opportunity also to look at that WebAssembly-based rendering, even the new auto mode. So I'm going to create a new project here. I'm going to create a new Blazor web app, and I'm going to select some slightly different options. Let's call this render Blazor render modes. Okay, and that looks good. dotnet 9. And instead of just saying to enable just the interactive server rendering, I want both server and WebAssembly, which will enable auto. And then, yeah, we'll leave per page or component as the scope of that interactivity. Okay, so we'll go ahead and create that. Okay, now what I want to do is, you can see now in this app, let me zoom in here, we have 2 projects. This is the server project. That's just an ASP.NET Core project. It's going to run from the server. That's where a lot of our components are actually going to still run from. Any server-side rendering will happen from there. But we also now have this client project. That's the part that will actually be downloaded to the browser and run on WebAssembly. And right now, there's only just one component in that project, the counter component, that's going to run interactively on WebAssembly. So what I'm going to do in here is let's add, actually first, let's go into our layout. Let's go into main layout. And up here in the sort of the top, top row of the app in the layout, I'm just add some text. I'm going to put the render mode, and we're going to use this new renderer info API to get the name of the current render mode. So we can know, okay, is this static server-side rendering? Is this interactive server rendering? Is this WebAssembly? That name will tell us what kind of rendering are we currently doing, at least for the layout part of the top level of the app, okay? And then in the counter, I'm gonna add, let's just add like an H3 heading here, similar deal, render mode. We'll put what render mode is the counter using? Right here, again, using that renderer info API, we'll just print out the name. Okay, and maybe one behavior difference I want to do, depending on the render mode in this counter component, is, well, the counter button won't work if it's not being rendered interactively. If it's just being rendered from the server, well, there's nothing to handle the on-click event, so it just won't function. So why don't we do like an if check here? So if render info, and then it has this nice convenience property, this is interactive property. Yeah, we'll just let Copilot generate a bunch of stuff for us. That looks good. Then if it's interactive, we'll render the button, right? Because then the button should work. If we're not interactive, I don't know what this is saying. Delete that. We'll say like, wait for it. Okay, like it's not ready yet. The button's not going to show up until we're actually rendering interactively. Now this app is set up. You can see at the top, it's set up for interactive auto rendering. So what's going to happen here? This is pretty fancy. The counter page will first pre-render from the server statically, like we'll give you some HTML right away. And then if the .NET WebAssembly runtime has already been downloaded and cached, it will use it. It'll run on WebAssembly. If it hasn't been downloaded and cached, then it will set up the WebSocket and run interactively through with the server, while the .NET WebAssembly runtime is being downloaded and cached. And then on subsequent visits, it will switch over to WebAssembly because the runtime will then be available. So we should be able to see all of that by looking at the render info using this new .NET 9 API. Now, just a word of caution, but a word of guidance. This auto render mode is honestly probably the most complicated Blazor rendering mode. Like, remember, your components are running on both sides of the wire. And so when you're writing your component code, you do need to think about that. Like, you can't just write code that talks to the database directly, kind of like what we were doing with the movie app, because, well, what if it's running on WebAssembly? You can't talk to the database directly. So you have to do things like set up service abstractions that have different implementations, depending whether you're in the client part or the server part and so forth. So, use this functionality wisely. If you don't really need the complexity, then you don't need to jump into it. But for some apps, it does absolutely make sense. Okay, so let's go ahead and run this and see what it does. Okay, so up here at the top, we can see the render mode for the layout. Like, what is the layout doing? And so this page, like we said before, it's just being rendered statically for the weather page. Again, also being rendered statically. It happens to be using streaming rendering too, but we know it's just being rendered statically from the server. Now, if we browse to the counter page, you're gonna have to watch carefully. Watch for it. Okay, so I click on counter. Okay, oh, it looks like I have a little extra paren there, but whatever. Did you see it? Like, there was a brief flash where it said static before it switched to server. Okay, and why was there that brief flash of static? Well, initially the page got pre-rendered from the server. That's the static render. Pre-rendering and static pre-rendering really is just static rendering, but it's sort of the first request. And then it set up the WebSocket and switched over to server rendering, interactive server rendering really quickly. Okay, and then we've got our button. So we don't even see like any like wait for it text for our button. That paren is really bugging me. Let me fix that. Where is that paren? Where is it? Somewhere. I don't even see it. Where's the line 19? Oh, thank you. You guys are great. Much better. Okay, so we're doing interactive server rendering. Now in the background, the WebAssembly runtime should have been downloaded in cache. So if I refresh this page, it should now switch over. Now let's see what happens. Now I'm going to refresh. Okay, now it said static. That time you probably saw static pretty clearly, right? It was almost a second where it said static. That was again the pre-rendering from the server. Even when you're running on, when you say you want to run on WebAssembly, in .NET 8, we by default will still pre-render. So you get pixels on the screen as fast as possible while the WebAssembly runtime then boots up. So that was the pre-render, and now it's running on WebAssembly. So let's refresh it one more time. It says static, wait for it, and then we get the button, and now we're running on WebAssembly. And we'll run on WebAssembly for all future requests because we've cached the runtime. Okay? Now notice also up above that the layout is still rendering statically. So the outer parts of this page were rendered statically from the server, and then we have a little island of auto, an island of WebAssembly rendering that initially was interactive server rendering. Man, say all this stuff 5 times fast. It's kind of involved within what is otherwise a static rendering context. So that's the level of flexibility that you get with Blazor, and you can now detect all that thanks to this new renderer info API. Okay, cool. Let's go move on. Okay, Blazor server improvements. We have a new improved reconnection experience for Blazor server apps. Blazor server apps require that WebSocket connection to function, right? If that connection goes down, then the app doesn't work because there's nothing to be able to handle the UI events with. We had a reconnection UI that we shipped with Blazor server for a long time, and it was kind of clunky. We have a new one that we think makes the end user experience of your apps a little bit better. We also now have enabled WebSocket compression by default. So the payloads that Blazor server sends across that WebSocket connection are significantly smaller, which should help with UI latency. All right, let me show you the new reconnection experience. Let's go back to our Visual Studio instance, and let's create a new app. We'll go back to a just plain old interactive server rendering. We'll call this Blazor reconnection. And we use .NET 9, and we'll go back to just the defaults, just Blazor server. Oh, wait. No, cancel. Actually, I'm going to start out with .NET 8. I'm going to show you the .NET 8 experience, and then we'll show you the improved version. Whew. Sure. Okay. So this is a .NET 8 Blazor web app using interactive server rendering. And I'm actually going to run this from the command line so I can control when the browser refreshes. I don't want Visual Studio injecting things for this demo. It'll complicate things. So I'm going to open in the File Explorer, and then we'll just bring up the command prompt at this location. And we'll just do a .NET run to get this running so I can shut down the server at my whim, cause server failures to my heart's desire. Okay, so we've got our app running. Let's get it open in the browser. And here on the counter page, this is using interactive server rendering now. We should have a WebSocket connection. Now with .NET 8, if I shut down the server, and this could happen like the server literally crashes, or maybe you deploy an update and it has to recycle. If the server goes away, then any state associated with that circuit, is what we call it, with that user that's using your app, is gone. Will go away as well. And so the UI won't know what to do, and it will try to reconnect, and then eventually it will potentially give up. So if I shut down the server, you can see in the background, Blazor's detected that, oh, where'd the server go? And it's trying to reconnect. Like maybe this was just a network issue, right? Like you went into a tunnel or something. Maybe it's still there, and it's polling it and trying to see, can I get back to the server? But eventually, if it finds out, like, the circuit is gone, the state isn't there anymore, then it'll just stop. Okay, and this will happen even if the server comes back up. So if I restart the server, so I'm going to do .NET run to bring the server back up. Okay, so the server is running. Now, I mean, this white complete overlay is kind of clunky in and of itself, not a great UX experience. And the server is running. Why isn't it doing anything? That's because the retry interval by default in .NET 8 was actually pretty long. It's like 20 seconds, I think. So it's taking. Okay, there it's up. Yeah, okay, so it was able to now reconnect. It took like 20 seconds, so the user's sitting there waiting. But then it found out like, hey, my state is gone. I was able to create a network connection, but all the state I was using is no longer there, like the state of my counter, like that, what the counter was at. And then it just gives up and says, user, I'm sorry, I'm broken. Try refreshing the browser. That's what this is saying. And if the user refreshes the browser, it will work. It'll create a new circuit and basically start them from ground zero. So not a great user experience. Can we make this better? So let's shut this down. And then we're going to upgrade this app now to .NET 9. So I'm just going to change the target framework to .NET 9 and see how the reconnection experience has now been improved. Oh, sorry about my voice. Okay, so this is now a .NET 9 Blazor server app. And if we click the counter, it's working. Let's say something happens to our server again. Oh, no, did I just run it from Visual Studio? I just ran it from Visual Studio. I don't want to do that. I want to run it from command line. There we go. I thought I shut it down. Did I shut it down? No, it's not. Okay, there, now shut it down. Right, so now let's run it from the command line. Okay, perfect. All right, so now the app's running. The user's using our app. They're happily clicking our counter, trying to set a new record. And then we shut down the server. So we get a new UX experience, a little less intrusive, a little bit nicer. It's doing the same thing. It's trying to get back to the server, reestablish that connection. Let's bring the server back up. Okay, now the server is up. And then fairly quickly now, the retry interval is much shorter. It does have like an exponential back off, like it'll try over longer intervals over a period of time, but it comes up quicker. And now instead of it being in this broken state, when it finds out, oh, wait, my circuit's gone, it just says, you know what, I'm going to go ahead and auto refresh the browser for you, create a new circuit. So at least the app is working. This is something that you could have done manually with .NET 8, but in .NET 9, we're just going to do it for you because everyone ends up wanting to do this anyway. Okay, so those are the improvements. Now it is worth noting that we still did lose our state. Like the value for the counters is gone. If you want to persist, like maintain that circuit state for situations like this, that's something you have to actually do in your application. Like you have to take any state from your components and save them someplace that you can rehydrate them at some later point if that's what you want to do. So we don't help you with state persistence, at least not at this point. It's something we'd like to do on our future roadmap. But at least for the reconnection experience, that's a little better in .NET 9. All right. Optimizing page load and startup time. So web apps obviously have lots of static assets, static files that make up the app. Blazor WebAssembly apps in particular have a bunch of them. So we try really hard to optimize how those static files get delivered from your application to the browser. Now, for most apps, the set of static assets that you have, the set of static files, is actually known at like build time. There's no reason for you to like wait until runtime to figure out what those static files are. And so with that information, we can do a bunch of optimizations. So in .NET 9, during your build, we will actually figure out like what are all your static assets that you've got and which ones are files that were already compressed, like like an image or a font file or something like that, and which ones might we be able to do interesting things with, like enable compression and cache better. So we collect all that data and then now use that information at runtime to more efficiently serve your static files to the client. So we will now do pre-compression for any uncompressed static files in any ASP.NET Core app. This isn't actually really Blazor specific. This will work for a Razor Pages app or for an MVC application. If you have like JavaScript files or CSS files, ASP.NET Core will now detect those and say, hey, I can help you out with those. I will pre-compress them and do other nice things for you to make them serving them more efficient. We can do fingerprinting based off of the content of those files. Make the file names for those files unique so that they can be more aggressively cached, and to avoid caching issues where the file gets cached by something and then you update it, but it has the same file name, and now you're dealing with a stale version of that file in your application. By fingerprinting all the file names, you avoid those problems. We can also do more clever things with caching. Once they all have unique file names, we can actually tell the browser, go ahead and cache this pretty much as long as you want, because it's not going to change. Once it does change, I'm just going to change the file name using a new fingerprint. So go ahead and cache this particular version of this file as long as you'd like. And we can also generate e-tags for these files that are based off of the content, which will help. Like today, we generate e-tags based off of the timestamp on the file, like when it was last modified. But that can change without the content changing. Like if you rebuild the file will be a newer version, but it might still have the same content. By using content-based e-tags, you can have much more efficient caching logic using those entity tags. Like I also mentioned earlier, we also do much faster. We did a bunch of work to make the .NET WebAssembly runtime start up faster, so that you have a less delay from when you tell the runtime to go and when you actually get interactive features. Hopefully, my voice will survive for the rest of this. We'll see. Okay, so let's look at some of these static web asset optimizations. All right, so I'm going to take, so this app is actually the Blazor reconnection app, and we started out with it being a .NET 8 app, right? So it's using the .NET 8 versions of handling static files. Like here, you can see it's using the good old use static files middleware that we've shipped since the beginning of ASP.NET Core. And this middleware, what it does is it takes the request and it knows about static files in like particular places, like your web root, and then it looks in the file system and says, well, is there a file here at that location? Yes, okay, then I'll serve it. So it's always going to disk and looking at the file system to serve up files. That can be problematic in some cases, like depending on which OS platform you're running on, you might get different behavior there. Windows file paths and Linux file paths, they're different, so that can be a problem. Also, with the middleware, you could sometimes end up with ambiguity on with your routes. Like if you set up a route in your app that just had like an open route variable for the path segment, it's not clear. Well, did you mean to serve a static file at that location, or did you mean to route to that route with just whatever the file name was at that route variable? So you can end up with these conflicts between static file serving and routing. And you also couldn't use a lot of the features in ASP.NET Core that rely on routing endpoint metadata with the static file middleware, because the static files weren't endpoints; they were just files on disk. So in the new system, let's create a new project so we can see what the new system looks like. Sure, Blazor App 1, that's fine. And this one will be .NET 9. There's a new API. So we look in program CS in this one. Instead of use static files, it's now map static assets. And this is actually setting up all of your static assets, your static files, as proper endpoints. So all the features that require endpoint metadata now work. Like if you want to set up authorization rules for one of your static files, you can now do that because they're proper endpoints. We take care of all the differences between different platform file path handling. That's no longer an issue because we're just doing routing here. And honestly, all the hard work of figuring out which static files to serve gets all done at build time. So you don't have that extra work that happens at runtime, which makes this API actually more efficient than the use static files version. Okay, so it's set up to use the new map static assets feature. And what I'm going to do is I'm going to go ahead and publish this app. A lot of the optimizations that we do based off of the static asset metadata will happen on publish. So let's go ahead and publish. Okay, then we'll publish to a folder on disk. Good, and go ahead and publish that. Okay, so as part of building and publishing ASP.NET Core, we'll figure out where all my static files are and then do a whole bunch of nice optimizations for me. So let's go ahead and run the app and see what those are. So we got the app running. This is the published version of the app, important. Okay, so now if we refresh, do a hard refresh without any caching, let's see what we got. Okay, so notice a couple things. Zoom in here. So like our bootstrap.min.css file, notice that it's now bootstrap.min.css. So it's now a fingerprinted file name. It's got a content hash in the file name, which makes it unique. And that allows us to do all sorts of great things. So like if we look at some of the headers that are being sent for this file, you can see that, well, first of all, the cache control header is set to say, you know what? This file is immutable. It's not going to change. So you can cache it as long as you like. And if you don't support the immutable cache control header, the max age is really long, like a year, I think is what that works out to. So that's one thing. You can see that the content encoding for this file is broadly compressed. We've done pre-compression of Blazor web apps for a long, long time. This now enables that pre-compression feature for any ASP.NET Core web application. So we, at build time, at publish time, did broadly compression on all of these uncompressed static assets, and we're serving the compressed versions. You can see also that the E tags down here, these are content-based E tags for the file. So this is based on the content of the file, not just on some timestamp. And if we look at the size of the file, let's go look at, like, hover over here. See if that can work. Well, I don't know if you can see it, but it says like this was 17.8 kilobytes transferred over the network, but the actual resource size is 163 kilobytes. So we're getting the benefits of doing, build time, broadly compression, cranked up to 11 as far as it will go to really shrink this file down as far as much as we can. And this was done for all of the static assets that hadn't been already compressed, like app.css has got the fingerprint, our component-specific style bundle, the Blazor app 1.styles.css, same benefits for those files as well. Okay, so that's all the new benefits there. A couple of things that are worth pointing out in this app. If you want to use those fingerprinted files, you might wonder, well, how do I figure out what the fingerprinted file name is? Well, in all the places in Blazor and MVC and Razor pages where the framework is handling those file names, we take care of mapping them to the fingerprinted file names for you. So like tag helpers for like the link tag helper or the script tag helper, when you point to some CSS file or a JavaScript file, the tag helper will take care of saying, oh, you really actually want the fingerprinted file name. Now, in other places where there's no framework code in the middle to do that automatically for you, we provide an API where you can do that mapping yourself. So here in app.razor, you can see that instead of just saying, here's the bootstrap file, we're doing something a little, get rid of that little pop-up. We're doing something a little bit fancier here. We're calling this assets API to say, well, the asset I want is this guy, and please use the fingerprinted version of that for me. Okay. Now, if you don't use this assets API and you just put the file name in, it will still work. Like we'll still serve up that file. You won't get the fingerprinted version. It won't have like immutable cache headers, but you'll still get the nice E tags because that's still relevant. Okay. So it's backwards compatible, but you also have the ability to use all the new features. There's also this import map component here in Blazor. This is setting up JavaScript import maps to tell any JavaScript module loading, hey, when you load that JavaScript file, actually use the fingerprinted file instead. That's what that's doing under the covers. Okay, so that's available for any ASP.NET Core app. Like this is a Blazor app, but if I went and created a Razor Pages app, you get all the same features there too. I won't do the whole publish and show you all the wire format, but just to show you the setup, in the template, we now are again using that map static assets call instead of use static files. There's an additional call here with Razor Pages and MVC to say, with static assets, like telling the tag helpers and stuff like, hey, I want you to use the new features. So there's one extra API call for MVC and Razor Pages. For the import map and all those things, let's go look in the layout. So here, all the tag helpers are actually doing all the mapping for us. So everywhere you see this sort of green teal look, that means that there's tag helper code that's associated with that link tag that will take care of using the fingerprinted file names. And then here's this script tag. Let me do this. This script tag has a tag helper for MVC and Razor Pages that will also set up that import map that we saw in the Blazor app, the thing that the import map component was taking care of. So all the same features for regardless of what type of ASP.NET Core app you're actually using. Pretty nice. Okay, some other developer experience improvements for Blazor. We now support constructor injection into your Blazor components. This is nice if you want to optionally inject a service into a component. And by the way, it's in addition to the existing @inject property-based service injection that we've supported in Blazor for forever. You can now just define a constructor and inject services through that constructor. So optional services, and also it works much better with null state checking if you're using that in your Blazor web apps. For tooling, we've been doing a lot of work to make hot reload better. We've received a lot of feedback that it can be a little janky at times, not always fast, not always reliable. We're working really hard to make hot reload solid. A lot of that involves a lot of really significant architecture work that's happening on the Razor compiler. The Roslyn folks, the people that build the C# compiler, have been helping us out with that. If you remember, I don't know how many of you were around back in the Roslyn days, but it was sort of this 5-year journey of rebuilding the C# compiler. We're kind of going through that with the Razor compiler right now, where they looked at what we did on the ASP.NET Core team and were like, you guys really aren't compiler devs, are you? And we're like, no, please take this from us, make it good. And so they're taking the Razor compiler, making it good, that will address a bunch of these issues with hot reload and also with some of the Razor editor problems that we've been having. So improvements to the Razor tooling as well. Blazor WebAssembly debugging is also getting a nice upgrade. I'll show you that in a second. And we also have a new Blazor Hybrid Plus Web project template that you can use for you Blazor Hybrid users out there. This is a way that you can build a single set of components that can be reused for a web app and also native mobile and desktop apps built with .NET MAUI. So I'll show you a couple. Whoa, we're way ahead now. I'll show you a bunch of those things. Let me go back to right here. Okay, actually pop it out. Let's look at debugging. So for debugging, I think we can go back to our reconnection app. No, not reconnection, the render mode app. That had WebAssembly in it. Okay, and what I'm gonna do is I'm just gonna go ahead and debug this using the old tooling experience, and then I'll show you how you enable the new tooling experience. So I'm gonna go ahead and run this, just F5. Okay, so now, yeah. There it goes. Okay, so here's our app, and then the counter component should be, whoa. What just happened? I don't know what that was. Continue. Refresh. It's not valid JSON syntax. I'm going to retrieve source. What is this? The code for the counter? That should be fine. That's just content, right? It shouldn't matter. Let me rebuild it. Stop. Preview bits. Build, rebuild. Okay, let's try one more time. So still .NET 9, preview Visual Studio. Let's see if we can get this going. Okay, great. Something got stale there. Okay, so currently we're on server. We want to get to WebAssembly. Switch to WebAssembly. Why are we not switching to WebAssembly? Okay, there we go. We're on WebAssembly. I think it just took a little while for the WebAssembly runtime to start up. Okay, so now I want to set a breakpoint in my increment count method. All right, and let's see what happens when we click the button and get into the debugger. So this is the current debugging experience for Blazor Web Apps. And if we look at our counter, some things that are not so nice here. So first of all, you see that it's a little hard to see. If I do it like that, yeah. So the current count, right, is currently showing up in the debugger as a number. And why is that? Well, debugging Blazor WebAssembly apps is a pretty fancy piece of technology. We're actually like debugging .NET code running in the .NET runtime on WebAssembly in a browser through the JavaScript debugging protocol. So some JavaScript debugging isms kind of like leak through right now in the Blazor WebAssembly debugging experience. Like that should be an int, a .NET int, but because we're mapping it to JavaScript stuff, it shows up as a JavaScript number. So that's a little weird. And if we look at the call stack has got all this weird, like there's the .NET stuff, but then we've got all this other weird gobbledygook in here that I don't even know what that is. And it's pretty messy. There's a bunch of things also that just don't work. Like I can't use the modules window, some expressions in like, the immediate window don't function correctly. It's kind of like, I mean, it's useful, but it's not what you would expect from a true .NET debugging experience. Okay, so we have a new experience that we've been working on that works with .NET 9 apps. So you need to be on .NET 9 to use this, and you have to turn it on. So I'm going to search in here for enable .NET 9 mono debugger. Okay, this is the setting that's available in the Visual Studio preview channel. I'm going to go ahead and click that to enable the new debugging experience. And let's see if we can improve on some of these things. All right, so we'll restart the app. Wait for it to wire up. Okay, and we'll click the button. All right, so now we're in the debugger. And let's see, do we get anything improved? Okay, good. So you can see down below my current count is now actually showing up as a .NET int. So that looks nice. You can see that the call stack has been all cleaned up. We will now honor just my code settings with the new Blazor WebAssembly debugger. If you want to use the, modules window, that will now load properly with the Blazor WebAssembly debugger. If you want to like go into the intermediate window or set breakpoints that are based off of expressions, the expression handling is a lot better than it was with the previous debugger. Like if I say this dot renderer info dot name, I think that should work, right? Yeah, it tells me that I'm running on WebAssembly. So expression parsing is also much better. So that's the new Blazor WebAssembly debugging experience that's coming with Visual Studio and .NET 9. You do have to turn it on, though, in order to see it. So make sure you flip that setting and target .NET 9. All right. More stuff to cover. We gotta get going. How are we doing? We're at, we got 15 minutes. I do want to show the new Blazor Hybrid plus Web template. So if you go File, New Project, you will need to install the Maui workload in order to see this. But if we filter to Blazor Hybrid or Maui, you can see there's the old Blazor Hybrid, well, not old, the existing Blazor Hybrid app template. And now here's the new one that's Blazor Hybrid and Web App template. And this will set up both a web app and a .NET Maui app to use the same Blazor components for their UI. So let's go ahead and create that. And yeah, that looks good. All right, so I have now a solution with 3 projects, right? I've got the .NET Maui project. That's going to host my components for mobile and native desktop. I've got my shared project. That's the one that actually contains the Blazor components that really make up my app. And then I have a web project, which is a Blazor web app that hosts those same components too. Okay, so all the pages are right in here. And so we should be able to run for mobile, desktop, and web. Let's see if we can do all 3. We'll try to do as fast as we can. Let's switch it to the web project and get web running. Okay, and I meant to, let's close that. Let's also make a little update to the UI so that we know that it's actually doing something vslive specific. So hey vslive, save that and hot reload that in. So that should pop up in here. Sometimes it takes a second because we're dealing with so much tooling in the way here. No? Well, we should restart it then. So I want to see vslive. Let's see. Okay, hello vslive. Okay, so that was web. Let's now go back to the Maui project and we'll run on Windows. So this is going to build and deploy a WinUI 3 based Maui application, a native Windows shell that's hosting WebView 2, that's rendering our Blazor components all in process. True native client app. There it goes. Okay, so we got now a native desktop shell showing the same UI. So we got web and desktop. And I could also do mobile, I think. So Android, on my laptop, Android takes like minutes to actually get it deployed to the mobile emulator. But I think I have one already deployed here. We'll just pick one of the existing ones. And trust me, if you deploy it to mobile, that also works as well. So we've got web, desktop. Wait, I'll make sure the mobile app's going to launch. There it goes. Yeah, the emulator for me is, for some reason, on this laptop is super slow. Yeah, so web, mobile, and desktop, all with one template. And you can just edit your components in one place and have it affect all 3. So that's the new Blazor Hybrid and Web App template. Cool. Close all that down. All right, so here's a summary of all the new Blazor stuff that's coming in .NET 9. Definitely worth checking out. What about the rest of ASP.NET Core. There's a bunch of new features in the rest of ASP.NET Core as well. What about for minimal API development or just API development in general? Well, we now have built-in OpenAPI generation support available with .NET 9. OpenAPI is a spec format for defining the sort of the structure of an API, like what requests and responses it can receive and send, what the structure of the message payloads looks like, and it's really useful for like integrating with third-party tooling for testing your APIs and for setting up programmatic clients and a whole bunch of other useful stuff. So we want to have a really great open API experience in ASP.NET Core. So we've decided to bring that closer to the framework. This is turning out to be also a really important technology for things like AI. Like if you want to have plugins for your AI models that are based on APIs, they generally have open API specs. That's how the model sort of learns about what the APIs are that it can call. So it's something that we want to have more built-in support for. The open API support we're shipping can do both runtime and build time document generation. You can fully customize the documents using transformers, document and operation transformers. Transformers are kind of like filters if you're an MVC developer. You can wire up existing testing packages, like the existing Swashbuckle Swagger UI package works with the new Open API document generation. And it is also fully native AOT compatible. So if you want to use it in an API that you're using with the .NET native AOT toolchain, you can absolutely do that. So I'll show you that real quick. Let's go into Visual Studio and we'll create a new API with .NET 9. Let's do ASP.NET Core Web API. And sure, that's a fine name. We use .NET 9, and I'm going to make sure that I've got this Enable Open API Support checkbox checked down here at the bottom. It's going to set up Open API support for me. And there we go. Okay, so here in Program CS, here are the two APIs that you need in order to set up Open API support. There's this add Open API call to configure the services, and then there's this map Open API call that will set up the endpoint for the generated Open API document. Okay, so if we just go ahead and run, and by the way, these require a package. This Microsoft ASP.NET Core Open API package. It's actually an existing package. We had it in .NET 8, but it didn't really do much. All the new Open API generation has been put into that existing package. All right, let's go ahead and run this, and we'll see the lovely JSON Open API doc. I think it's Open API v1.json, and there it is. So, a JSON document that describes the structure of our weather forecast API. Now, in the past, we also would wire up the Swashbuckle Swagger UI for you. We decided not to do that anymore because there's so many options these days for the Swagger UI or test tooling that you want to use with your Open API docs, but you can absolutely still use it. So if I go into my dependencies and say manage NuGet packages, and let's go ahead and grab the Swashbuckle ASP.NET Core, and then what is it, Swagger UI package. We'll go ahead and install that. And then what you do, this package is completely independent of the rest of Swashbuckle. It's just the prepackaged Swagger UI. You can then go in here and say, and you want to do this in your development environment. This is not a UI you want to publish in production. Use Swagger with a W, Swagger UI. And we do have to pass in some options, an option, to tell it where the Swagger document is. So we say options.swagger endpoint, and we tell it that it is at, what was it, Open API /v1.json, and then you got to give it a name. Okay, and that should work. So I'm going to go ahead and rerun that. Cool, and then we go to Swagger, which is the endpoint that sets up, and we can see our weather forecast endpoint here in the Swagger UI. Visual Studio also does have tooling though that lets you, visualize your APIs, see the endpoints, and test them. Instead of using the Swagger UI, if I just go to, actually I can just search for it. If I just search for endpoints, you'll find this Endpoints Explorer view, which Visual Studio will inspect your code, look for all the API endpoints you have, and display them here on the right, on the left. And then you can do things like right-click and say, go to the code for that endpoint, because it's knows where the code is, and you can also ask it to generate requests for that particular endpoint. When you do generate requests, what it will do is it will use these .http files, which are like a way to quickly sort of template out the HTTP requests that you want to send to your API, and then quickly run them and test them as sort of like an interactive API testing experience. So if I click send request here for my weather endpoint, I can get that same response, and I can look at all the raw JSON and see all the headers as well. So that's another way that you can test your APIs using the built-in Visual Studio tooling. Okay, so that's the built-in open API spec generation. How much time do I got? We only got 5 minutes. I think we'll leave it at that. You can also generate the open API spec at build time. There's a package that you just add, and then it will generate the JSON file as part of your build. For you SignalR fans out there, we've done some SignalR improvements. In your SignalR hubs, you can now use polymorphic types. So if you want to accept a base class in one of your hub methods and then have actually be sent derived classes from that base class, that now is supported with SignalR hubs. And then we've also improved the SignalR activity tracing, so that instead of having just sort of one big long request for your SignalR interactions, we actually create separate tracing activities for each hub method invocation without a long-running parent activity. So they kind of just look like request-reply actions, like any other HTTP request that shows up in your activity tracing. This is what it looks like in the Aspire dashboard. Caching, maybe you do use distributed caching in your ASP.NET Core apps. We have an existing abstraction that we provide for doing distributed caching, which is iDistributed Cache. But it's not the friendliest of APIs. It results in kind of verbose and complex code. All it gives you is this method get that returns a nullable byte array. And so you have to check if it's null, and then you're in charge of all the serialization code. It's kind of an inefficient contract because you're allocating all these byte arrays, and there's no good way to really pool them. The API is susceptible to caching problems like cache stampede. Cache stampeding is when you have like some requests that come in and they all have the same cache key, but if there's a cache miss, a cache stampede is when, well, all those cache misses result in that long-running expensive operation that you're trying to avoid through caching. They all happen together, and then you get all the responses back, and they all kind of write over each other, and so you wasted a bunch of server resources. Ideally, you want to identify that that's happened and just have one request occur, and then you kind of return cache responses for the other requests. iDistributed cache also is just a single tier cache, like it's a distributed cache for like dealing with Redis or those types of systems. But what if you want to do multi-tier? Like what if you want to have like in-memory caching as well as using distributed caching in sort of layers? So you use cache data in process if you can, and then only go to like Redis if you need to, and then only go to the actual expensive operation when both those layers of caching failed. So if you try to use iDistributed Cache today, you end up with code that looks kind of like this, and even this code's a little bit naive, so it's quite a bit of logic, a little bit tricky to get right. So in .NET 9, we're introducing a new hybrid cache API that just works for most cases. It has a bunch of really nice enhanced features. It has built-in serialization using system text JSON, so it'll just deal with serialization for you. It will do stampede protection, so it'll detect that case where you have a bunch of requests that are all requesting the same cache key, but they all miss, and it'll kind of queue them up all behind each other. It will do multi-tier caching, so it will use local in-process caching first, and then fall back to distributed cache if it's not available in process. It has a really efficient, low allocation-based API. Supports tagging and invalidation and a whole bunch of other advanced options. So that's what the new code looks like. It's really just one line. You just call get or create async. You pass in the cache key that you want to use, and then you actually give it the delegate for the thing that gets the data, so it can manage that process. And then you can also give it a cancellation token. It is not actually tied to .NET 9. It also supports down level. So if you want to use it on older ASP.NET Core versions, or even on .NET Framework, it supports .NET Standard, you can do that too. It's just shipping as part of the .NET 9 wave. All right, lastly, some small developer experience improvements. The developer exception page has gotten a couple of upgrades in .NET 9. It will show you endpoint metadata on the developer exception page, and the UX has been cleaned up, so it's a little easier to read. It supports dark mode now and all those things. And we've also done some improvements to debugging dictionaries using the .NET debugger, so that all those ASP.NET Core dictionaries, like the header collections or the query string collections, they all render nicely with just showing the dictionary key and the actual value without having to click and debug to get into things. Yeah, I think I was going to show you that, but I think we are at time, and those are pretty small demos anyway. So that's all the new stuff that's coming in ASP.NET Core in .NET 9. You can give them all these features a try by going to .NET/next. That's where you can install the latest .NET preview version for .NET 9. Thank you all for sticking it out with me. I apologize for my croaky voice. It is on the way out, but I hope you enjoyed learning about these features, and I'd be happy to stick around and answer a few questions.